All right, today we're going to talk about what's the value of a scoop. And we're going to do a little exploration. The reason why we're doing this exploration is because last week I gave you guys some word problems. Remember those word problems?
Yes.
And you guys were working in teams. And you guys did a great job solving these different ways. So here's an example of what one group did. They had 9 cups of flour, and the question was how many 1/3 cups of flour can you get from the 9 cups? So this group identified the cups this way: 1 cup, 2 cups, 3 cups, 4, 5, 6, 7, 8, 9 cups of flour. And then they took this geoboard and they divided them into thirds because each cup would get 1/3. So you see how they divide them into thirds vertically?
Yes.
And so the question was how many 1/3 can you get out of 9 cups? Well, after doing all this work, this group could not decide if the answer was 9/27 or 27. Can anybody see where they would get 9/27 from, just looking at their work? Diamond?
The reason we get 9/27 from is because they thought like how many thirds did you take from 1/9, so they started.
1/9?
I mean
1.
27. No, 1/3.
They took 1/3 from each. Go ahead, help her out. What'd you say? Each cup,
Yeah.
right?
Yeah, from
So
the
you can
cup.
see there are 9. They took 1/3 from each cup.
Yes, and then it was 9 in all, so they just put 9/27.
Okay, and where would the 27 come? Where would this 27 come from? There's 27 pieces. How would the answer maybe be 27? Dennis?
Because they're 27 in all.
There's 27 pieces in all. So some of us could do all this work, but we didn't know what answer was correct. So we're going to do some work today to try to help us decide when do I want to take 1/3 from each cup and when do I want to look at how many pieces we make. Okay? I was going to show you some work from some other groups. This was a group where there were 3 pizzas and each child got 1/4 of a pizza. And then they could feed 12 children. So this is, anybody remember the name of this kind of model? So what do you do when you draw pictures and divide them up? What kind of model? Well, it's part of a set. It could be a set model or area model. Either one. Good. Either one works. All right, and this was an example where there was 9 meters of rope, and they wanted to cut pieces that were 1/4 of a meter long, and we wanted to know how many pieces we could make. And so this is another area model of that one. All right, and then this was another example of how many 1/4 cup servings are in 5 cups of rice. So here we have our 5 cups of rice. Each cup was divided into 4s. So now, do we take 1/4 from each, or do we count how many pieces do we have all together? So that's what we're going to make sure we understand today. Not all of us got it out of it. All right? So in a few minutes, we're going to do an exploration. So I'm going to talk to you about it now. Okay? You guys are going to be group 1, because center 1 says what? Water. You guys are group 2, because center 2 says?
Water.
Very good. Remember, we're going up and down on our sheet. Group 3 over here, you are? Oatmeal. And then group 4 is the cubes. Okay, so I know that's kind of weird, but we're kind of going around the outside of our room. What is it when we go around the outside of the finger? Perimeter. Very good. So we're going to kind of do the perimeter of our tables. Okay? So before we get started, I had you guys make some predictions. So I'm going to use this table as an example of what I had you guys do when we made a prediction. So on this table here, this is center 4. You have this is the cup, this is the container, your one container that you're going to fill up. This is the size of your scoops. Okay? Aren't they cute? Yeah, I got a lot from Kobe. Right? So these are our little scoops. Okay? These are the same exact size, just different colors. So you're going to scoop, fill it up however you feel necessary is equal to a scoop. You're then going to pour it into this container. So that would be 1 scoop. Should we stop?
No.
No, I want you to fill up the container. As a group, you're going to count. Now you can decide as a group. Are you going to take it turns and go around? Or are we going to each try to do it once? You're only going to have 5 minutes, so you might not have time for everybody to do it once. So you could pair up. You two might do the first scoops, and then you guys do it the second time. You just have to decide which way you want to do it. Okay? All right, so you're going to keep going, count your scoops, and then on the first line, you're going to write the number of scoops it takes. So let's look at how these are set up, because every part is set up the same. Let's look at number 1, where it says center 1 water. Let's read that question out loud.
How many scoops does it take to fill up one container?
All right, very good. Every question is the same. How many scoops does it take to fill 1 container? Do we know that yet?
No.
No, but you made a prediction. You made a guess based on 1 scoop. So you're going to go through and do this. If you do it more than once, you want to record your answers because you might get a different answer. If you get the same answer every time, you just have to write 1. All right, what's the second question say?
What is a scoop worth?
All right, so that's the tricky part. After doing that, I want to know what 1 scoop, how much is it worth out of a container? All right, and that's going to be where a lot of your discussion is going to take place. And so as we do this, you guys are going to come and meet with me after you hit this station. So let me explain that again. You're going to go around in order, 1, 2, 3, 4, and after 4, you're going to go to the table, which is going to meet with me, which is 5. And then after 5, you're going to go back to, we got to do all of them, back to 1. So like if you guys start, you're going to start here at 4, then you're going to go to the table with me at 5, and then where are you going to go?
Back to home base.
Back to 1, which or 2, 1 for the first time, and then you'll go around. You're going to have 5 minutes at every station. So when the alarm goes off, I'll ask you to stop. We'll set up your station. It should look exactly like it is right now. So the next group does it. I know some of you are going to get excited when you get close to your estimates or if you guessed exactly correct. But don't share your answer. If this group comes over here and says, finish this up, yes, it only took 1, and everybody heard it, they might write it, but I mean, does that make it fun for you guys when you get here if you know that it only took 1?
No.
No, so if you get your answer, don't get it's okay to get excited, but don't share your answer with everybody else because then you're going to ruin that fun for everybody else. Okay, so let's be considerate of each other and what we're trying to do. Anybody have a question? Yes?
So when we put,
But what do you have to make sure you do before you pour it all back in? You want to make sure you're counting how many it takes. Because that's the goal. We got to figure out how many scoops it takes, and then we're going to figure out what's the value of 1 scoop. That's our goal today. Yep. No, good question. We're not counting the blocks, we're counting your scoops. So when I did this and put it in here, that was just 1. Did I ever count the blocks? No. So don't count the objects in anything. Same thing with pattern molds. Do you guys want to count every scoop that's in that oatmeal?
No.
No. Questions? One more thing. When you do this station right here, make sure you use teamwork, because as you pour this into this hole,
It's gonna fall out.
it's going to fall out. So you might want to use some teamwork. Use teamwork in most of your stuff today, okay? All right, let me set the timer. Go.
Oh yeah.
Good teamwork.
Five, did it say 5? Isn't it? Is it full?
That's a good question. You guys have to make that decision. You guys have to make that decision. That's part of the process. All right, so make sure you record, and then you guys still have 3.5 minutes, so you can do it again and see if you get the same amount.
So, like this. I think when 7 was like we put 7 cups in there, and like it's only like one cup was worth, so I'm thinking 1 7 because 7 cups. Well, I don't think so. How many is it worth is here? Yeah, but do you call this full? Is it full? Yes, I call it full. Well, it's much. No, but worth doesn't mean I'm like a fraction. That's 7. How many are there?
Well, let's look at it. You guys, y'all have your answer recorded. Let's dump it. Alright, so let's just do 1 scoop.
We already did it. We just count those.
Just put it in the container because it's a part of the container, right?
How many?
Shouldn't it be
What
part of
is
the
this?
container? It says, what's the scoop worth for 1 container, right?
1/7.
Plus 1/7.
Yeah.
Alright, so
1/7.
Okay, so what would you now?
so then do it again. Make sure you get the same
We almost took all the box out of it. You know how it got almost this? 7. We can take it out.
Yeah, when you put this over here, you get it.
You want to take how many can go in there?
Yeah. But it's not.
Okay, good. Alright, so now start seeing if you guys can figure out what is 1 scoop worth. So we're going to do 1 scoop. You compare it to the whole container. And you guys have a discussion of what you think that's worth out of the whole container. How many times have you guys done this?
One. This is our second time. We're doing it like this. Alright, now we got that.
40, 50,
Oh yeah.
So it's
Yeah, but we didn't do it with the last one.
'Alright, so now we have to do what? Now we're done. No, we still gotta fill it.
that would be 116. So we got our
2.5. We gotta figure out what 1 scoop is.
Oh, just in time.
Alright, don't move yet. Reset your centers. Now, if you didn't get a chance to write down what 1 scoop is worth, you'll hopefully have a chance as you keep exploring this as you go on. So go ahead and switch. Remember, go to the next number. You guys are going to rotate.
We go to 4.
Alright, the time is started. Alright, so how did you guys do on that? How much did it take you?
6.
You take this to the water. You did make sure everybody has their own four. How many times did you do 6? No. How many times did you get to do the experiment? Did you only do it once? And both times you got 6. So you got the same answer. So you were consistent, meaning every time you did it, you guys did it. Alright, who could, Keelan, can you explain for me how you guys got 1 6 what the scoop is worth?
It wasn't
Alright, so how do you know that there was 6 total? Very good. So, I was Sorry, I had these from yesterday and I'm moving with them over. Alright, so you have your container. Y'all know I'm such a great drawer, right? So I have my container. So when you fill it up one time, was it at the top?
No, it's at the bottom.
It fills up at the bottom, right? So this will fill it one time. And how many times did you do it? 6. And when you did it 6 times, did it fill up all the way to the top? Did it never overflow? No. So you guys have it completely understood. So you had your 6 times, right? So it fills up. Alright, so here's my question. If it took 6 scoops to fill up one container, what if I added another container? How many scoops would it take to fill up just this one? If it was the same size, right? Does that matter? What if I made the container like the water container? Would it still be 6 or would it be different? What if I change the scoops up? What if instead of doing the little owl cups, it would be different, right? So this talks about using those owl cups in that same size container, right? So if there were 6 here, how many would fill this one? 6. So your scoop, we'll put an S, we use S for it. If a scoop equals 1/6, right? And I have 2 containers, how many scoops would it take? It's like doubling it. What'd you say? 6 plus 6 as well. So let's turn your paper over. And you see that up here, you have these are tables. What we're going to do is look at some algebraic reasoning, some repeated reasoning, some patterns. So this one, you guys did center fill, which is blocks. So we're going to start at the bottom. When you had one container, and you found out that the scoop was worth 1/6, how many scoops did it take you to fill that container? 6. So underneath one container, write a 6. And we just did the second one, right? If I had 2 containers and the scoop was worth 1/6, you would have how many in all of it? 12. So it would take 12 scoops. Because it would be 6 in one and 6 in another. What if you had 3 containers? Jack, why would it be easier? Why would I add 6 to the 12 that you already had? What do you mean you can multiply? Why times 3?
So this will go because it's like the same, but we didn't really know that one. Yeah. When we say that that's 3, and then 3
Good job. So why did you say 6? Did you say 6 times 3? Why did you say 6 times 3? 5. There you go. So you have 3 holes and each one's worth 6, right? Alright, what if I had a 4th container? Alright, so what do you think N stands for? What kind of number? Number of not numerator. Look at your table. Number of is that what the N is? Is it a scoop?
16.
Number of containers. So N's going to represent any number of containers. If I didn't tell you how many containers you have, is there a rule, is there a pattern to figure out how many scoops you would have? What would you do with the number of containers? Times 6 why? Go ahead and reset your center. Hold on. Make sure it's set up and then you can move. Go ahead, Cheyenne, thank you. Why would it be times 2? Are you going to multiply?
Yes, we
To fill one container. So however many containers you have, you're always going to have 6 in all. Total? So what in one whole container, there you go. So how would we write that? As an expression. You would take, is it always 1? You would take, what's your blank? What did I ask you to use for blank? What's your blank? N represents what? Number of containers. So what would you do with your number of containers? We'll talk about it tonight. Go ahead, I thought you guys were there. You guys did a good job being patient. Come on over. We'll get there.
So, my prediction was 3. What was your prediction? 6. What was your prediction? 3. 6. What was yours?
What amount?
Okay, so let's see.
So let's start with that. We're gonna move over to this one. Okay, so if you guys had one thing that
Need them rolled up.
it took 6 to 4
Oh,
hours.
that's not bad.
You know, sometimes the golden around the thing, they make like a little gold thing in it.
Very good. All right, so it's 1 out of 6, right? So then
So that's how much money.
like, because you guys wanted to do, this is 100.
They stick it all up,
This is
they pour it in.
half of it. So what's this one super? If there was only 2, that's 2 would be more.
Let's see, it's 3 right now.
Ooh, I have an experience. Let's see how many it takes with the hair. All 4 of my hair.
Yeah, it never fails. But if you push it,
Nah, you smush it. Not push it. Well, I can't say that. I said court. I court.
let's try with 2 and then let's try with 3 and see which
Yeah, 1 more time.
Alright, so.
Alright, here we go. This one ain't this
John, you can explain how 3/4 is the same as 6/8?
Yeah, I'm thinking it's gonna be 2 because look how much that is compared to a 3.
Okay, so you're saying take this one and divide by,
We ain't gonna be done.
divide by 2, right?
That's my prediction.
You mean your prediction?
I said prediction.
And the 2 isn't even filled up all the way. Yeah, but when we do 3,
Because you guys are trying to
let's try.
you guys have enough experience on that. Is I would make this a little so you guys can do that. If you want to keep it, you want to keep it actually. Alright, so prediction. Don't do it to the side. So you have 3
I think it's gonna be 3, but it's gonna overfill. Like, if you do 2, then it's not gonna be filled up.
It still ain't filled all the way right
Fills
there.
up to where like that.
Joel, you guys need to
Yeah.
be more careful.
So you still have that much.
Got 3.
Well, we need to check.
Okay, we only got 5. Put it back. Wait, it's kind of still.
Start cleaning up your station.
We did like one thing of like the container.
Dennis, your table is going to be coming here. So just hold on.
How would that be? Is it just like 1 half plus 1 half? So you would still need that?
Yeah, if you have 1 container, right? And you fill it out here, this is 1 scoop, this is your 2nd scoop. How much is this out of the whole container?
And then the other half, that'll be a whole.
Right? Good job. All right, go ahead and go to water, we'll talk some more. You guys are doing a good job. Thank you, Brian. The difference
I'm not predicting
Is that okay? You're allowed to predict or not get exactly. Are they close though?
Yeah.
So that means you're a good estimator. Do you know that if I was to make a prediction for this, I would be way off because I'm not spatial. Just like I can't draw, I'm a hard time like that. So if I made a prediction, like for this one, I might have predicted that there would be like 10. I'd be way off. You guys got how many there? 6.
we got right on there.
And that's okay. This isn't about being right or wrong. It's about understanding it. So the prediction part was just for us to kind of see how well you guys are. Do you have any questions so far? You guys look like you're totally on track. Is anybody confused about what the scoop is worth? All right. So you guys started at pattern blocks. So let's take that one. Tatiana, can you explain to me why you got the scooping with 1 7?
Because it was like, it took 1 scoop to get 7.
What do you mean 1 scoop got 7? Here's your container. You have the green container over there, right? So these are, hold on. So when I did this 1 scoop 1 time, I'm going to write what is for 1 scoop.
This is 4. 4 times it took 7 scoops.
Okay, so it took you 7 scoops. So then when you put 1 scoop in, where'd that go? When you took the pattern block and you did 1 scoop, where'd it go? Yeah, where did it fill up on the top? Yeah, because gravity, right, it brings it down. So here's your 1 scoop, and you had to do that how many times?
7.
And did you notice anything about your scoops?
Sometimes you thought they weren't even, so you just filled them up with solid.
Why would you try to make it even? Is that important?
Yeah, because it's like you have to do a circle and you put try to put and you're thinking the friends couldn't get
Oh, I like how you make that into pizza. If your friends don't get, if you have a whole pizza and you get 9 away or they all have different sizes, your friends aren't going to be happy that they're not the same size. So you guys did try to make them the same size, right?
And how much?
All right, and so if you have 1 scoop here, how much is it? Don't 7. You guys are doing a really good job. So let's flip over and talk about what we're going to be doing next. We're going to start with your center, which was pattern blocks. Okay, and you said that 1 scoop, and I'm going to write for 1 scoop. 1 scoop equals 1 container. So if you had 1 container of pattern blocks, and you have the same size scoop in the same container, and I wanted to fill up 1 container, how many times do you have to do it? 7 times. So underneath number 1 here on the pattern blocks, we're going to write that you guys have 7 scoops. So you 7 scoops, right? Alright, so let's pretend that I have exactly the same size container, and I use the same size scoop, and I want to do it for this container. How many scoops were in number 1? 7. How many scoops should it take for this container? It's exactly the same, right? So how many scoops do you need to do it all? 1.
It's just like doubling. You add both of them together and you have 14 scoops.
Good job. So adding it, that number is like doubling it. You know another way to say doubling something or adding? 40 times in 7 times 2, right? Okay. And technically, because that community property is actually 2 groups of 7, because it's 7 and 7. But can you say 7 times 2? Yeah, and in 5th grade especially, it's okay with you. Alright, so let's go ahead and fill that. If each scoop is worth 1 7, and you had 2 containers, you would have to do how many scoops? 14. So go ahead and fill that in now for this one. This is for 2 containers, right? And Denise is doing a nice job over here labeling it, but you guys don't have to. Because here, you see on the table, it's labeled for you right here. So is there only going to be 7 total scoops if I had 2 containers? Right. So you got 6. Because there's 7 in each. So if I have 2 containers, you have 7 and 7. What if I have a 3rd container?
Since you're adding you might need to or 7 times 3 is equals 21.
Very good. Circle it or add another 7 to give you 7 times 3 is 21. So go ahead and write that in. And then when we come back, we'll keep going when we get back together. So go ahead and do the next one. Good job cleaning up and rotating. should be your last station.
Yes.
All right, good. How you guys doing? All right, let's look at this side. And you guys have any questions for me at all on how you've done? Do you have any questions for me? You guys don't have any questions?
What was that? That's 5. No, that's 4 because all 4 of us.
Is it 1 cup? Or is it in a cup? That one's kind of hard. Well, we don't really know what the measurement is. We can't say it's 1 cup, but it's 1 cup, right?
1.5.
So, my first question is, every seal and jig, were they the same? About? They were about the same. So when you take one hole and you break it up into parts that are about the same, is that fraction amount? Yeah. So here, you took that and when you put this in, when I poured the scoop in, does it fill up the top?
Can I ask for the right on this?
Put 6 here.
I know, like, I'm right.
Right, but when you pour that one scoop, where does it go?
It goes to the bottom.
It goes to the bottom. So here's the bottom.
I got this. And
Your second scoop.
1, 2, 3, 7, 6.
6 and
You can't like cram. No, seriously, they can't cram it in there. Alright, you went first last time. I never went. Well, I was on first. I never went. I'll use my hand.
Alright, let's look, you guys start with the water. Right, so center one was and one scoop equals 1 cup. Now, if you have a table that has the number of containers and it has your number of scoops. So here, one container, and we're going to pretend the containers are the same and scoops the same. If I have one container, and each scoop is worth 1/7,
Dude, just try 1/2. What? No, you didn't do 1 whole.
No, they don't
Try a
count.
second container.
You can do 1/2.
And use the exact same.
Oh, this is
I tried 1/3. Really, I don't like this. Restart it, cause I can tell you to do 1 whole. Alright, I did like this. Asia. Not so bad.
That's 1. What if we have a third container? How many scoops would be in just that third one? That's the same size.
Yeah, that's good.
So do you know how many times we take this to all 3 containers? If you bring it. Alright. Can you tell me why?
3.
Because we have all 3 times. Tell me.
4.
7 times 3, which would be 5. So then how would you do it? We have 4 containers. We had a 4th container. And each scoop is worth 1/7. How many scoops would you roll? That's just that one. Yeah. How many scoops would you roll for 4 containers? Well,
I have done 7. And each one equals 1/7.
So you should kind of do the half and good job. So, go ahead and do that and then we're going to talk about it. Good job. All right. Clean up your station, go back to your original station, please. Please go back to your spot. What you guys need to make sure you do is kind of make sure you get some on the table, make sure it's dry. Because that's how that's it. There's a black one too. It's stable. Okay, it all pops up.
We just left it.
All right, very good. You guys did a great job on your explorations, and I loved our discussions that we had at the table. Don't worry about cleaning up, y'all. We're going to do that later. I appreciate you offering that support. What we're going to do now is we're going to come up here and we're going to record our answers. I'm going to give everybody a chance to record. So what I need you to do is decide at your table who's going to record the answers for water, who's going to do one for pattern blocks, who's going to do it for cubes, and who's going to do a cold bit. Everybody should be coming up. I'm going to give you 10 seconds to decide who's coming up for which. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, attention up here. You should have made a decision, and it's okay. Everybody will get a chance to write. So make explain what you're going to do. Remember, you're the group number of where you started. So you guys are 1, 2, 3, and 4. Group 1 will always record their answer on the top line. Group 2 will always be on the second row. Group 3 will always be in the third row, and then group 4 will be in the fourth. So the representative for water, look at the number of scoops it took you. The water person, please come up and record in the correct spot. Quickly. We're going to take turns. Joel doesn't have to be perfect, buddy. All right, good. Pattern block people, come on. Oatmeal people, come on. You decide. Which one? Talk about it. Which one is the easier for us to do to continue. So, and we'll talk about it as well. All right, in cubes. You're going to be trying to be impatient, taking your turn. Diamond, is that a 9 or a 7? That's a 7. It's okay. I'm just going to write. Where's it? All right, I want you to take a second and let's look at our data. Let's analyze it a little bit. And I want you to look for patterns just like we do all the time. This is extremely interesting. Does anybody notice any patterns of what we discovered as a class? Denise, what do you notice?
I've noticed that most of them got 7, and which one? Pattern block. Most of them got 7.
Okay, can you be a little more specific? What do you mean by most of them?
Like all 3 groups got 7.
All right, 3 groups for pattern blocks got 7. So 3 out of 4 got the same number, right? Could we generalize that for anything else? Oh, so 3 out of the 4 here are the same. we see that pattern anywhere else, Kayleani?
The number is either in front of it or like 7 in front of it is 6 and then 30 and then is 2. So it's close to the amount is close.
So the amounts are close to each other. Good job playing that up. You said they're one away. So meaning you either got 7 scoops or you got 6. So it's one less, right? Here you have 7 scoops or you had one more, right? Here you have 3 is the majority or you had 2, which was one less. And then here you have 6 or you got 7, which was one more. So she's saying you were kind of close together. It only was away by 1 scoop. Good job. Stephanie?
I noticed that on cubes, 3 out of 4 shows 6.
Yeah, here we have 3 out of 4.
They're basically the same on all of them.
Is it the same for all?
Yeah.
3 out of 4 chose, or not chose, but got 3. And so we actually have a pattern that's the same. That did not happen in the other class. So what that means is you guys did a better job being more precise. When we attend to precision, when we're trying to be exact, you guys did a better job making your scoops the same size. Whereas the other group yesterday, they were kind of all over the place. So you guys were more precise. So you didn't have as great of a variance or great of a range. Your range is really small because you guys use more precision. Cody?
And what I recognized was that every group got a different number.
What do you mean by that?
There was like the first group, they got, well,
Where were they different?
at oatmeal one. No,
Group 1.
on the cube.
Group 1 has a different number of cubes. Group 2
That's different award.
had water. I didn't notice that pattern. Group 3,
Had different
And
number.
oatmeal.
Oatmeal.
2 has different at water and oatmeal.
Group 2 has a different one at water and oatmeal. Actually, Group 3 was the same in all of them. Group 4
Had different number 8.
On
had pattern blocks, right? So you guys are doing a really good job at analyzing your data and reading it and interpreting it, which is going to take you a long way. All right, so we're going to keep going. Questions so far? All right, so let's flip over your, wait, don't flip your paper over yet. So after we did this, you guys then found the value of each scoop. Let me go back, we didn't do that for one of them. Let's see, let's take group 3 since they had the same. Let's take group 3 for oatmeal. So group 3 can't participate in this right now. Anybody out who can guess, and you guys are going to tell them if they're right. You're going to make an educated guess. What do you think the value of group 3's oatmeal scoop was worth based on their data? What do you think, Cody?
3.
So the scoop is worth 3?
No.
What was 1 scoop worth? Hold on, you guys have the same answer. That kind of leads it to 2. Anybody at 2 can give me an answer? Deja, do you know what 1 scoop would be worth?
1/2.
1/2? So we're looking at group 3 oatmeal. How many scoops did it take? Group 3. Not yours, group 3.
1.5.
What did, okay, you guys don't understand my question. Group 3, look at the data. What did group 3 have for oatmeal? 3 scoops. So what do you think is on their paper for the value of 1 scoop on group 3's paper?
1/3.
Denise?
1/3.
Why?
Because they have 3 scoops. They have, to fill up the container, they had 3. And it took them 1 scoop for every 3 they did.
Right, so if we look at what we're talking about, they said that the value of this scoop, I'm just going to kind of go fast. They're saying this is 1/3 of the container, right?
Yeah.
So what does that mean? That means if this is 1, then when they do it again, this would be maybe 2, and then when they do it again, this would be 3. So this is 1 out of 3 equal parts, right? So the value of this scoop is equal to 1/3 of this container. If I change the container to this one, is it going to still be 1/3? No, it would be something different, right? Let's think. If this is the scoop and this is the container,
This will be 1 whole.
it would be worth the whole thing, right? Good job. So that wasn't too tough, right? So does the scoop matter?
No.
Yes.
Yes. Does the size of the container matter?
Yes.
Yes. If we change it, then we change the problem.
It's the same thing when you do one with the bitty cups and you try to fill it with this.
Right. If we took those little bitty cups and tried to fill it up, then would it be something different? All right. So we had. If I was to put this into a story problem of what you guys did today, you had one container. And this time I'm going to tell you the value of the scoop. If the scoop is worth 1/3, how many scoops would it take to fill your container? 3. If I had 2 containers and the value of the scoop is 1/3 for 1 container, how many scoops would it take to fill 2 containers?
6.
Okay, why 6?
Because it's the same as double it.
So if there's 3 in this one,
And
there's going to be 3 in this one, and 3 and 3 give you
6.
6. All right, so let's go back to the problem last week that caused us some problems. I had 9 cups of flour. I want to know how many thirds are in 9 cups. So let's take a vote. Show of hands. How many agree that now the answer is 9/27? All right, and now how many of you think there's 27 pieces? Did you vote for the same? Put your hand up. Okay. All right, so we're still kind of split on this. You guys just found the value of a scoop.
Oh.
The value of the scoop makes a section. In this 1 meter, this was 1 meter, they divided it into thirds like the size of your scoops. How many scoops would it take to fill that cup of flour? 1 scoop, 2 scoops, 3 scoops. This is just like your little container here, right?
Right.
And when you poured in that scoop, it filled in 1/3. So it would take 3 scoops to fill it up. So how many scoops would it take to do 9 cups of flour? You still think it's 9/27?
No.
It's going to be
27.
4, 5 scoops, 6 scoops, 7 scoops, 8 scoops, 9, 10, 11,
12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Those of you still counting, you're nowhere with us.
27.
Nine times 3.
Okay, what'd you just say, Cody?
Not have 3.
How's that 9 times 3?
Yeah, you like all of them right there going 3 in a row.
Good, Elijah, keep going.
Like it was 9 and all of them while you count was like 3, 6. It was all 1, 3. So you multiply 9 times 3.
Because you have 9 groups of 3. So when you take those 9 holes and you divide them into thirds, do we get more pieces?
Yes.
Or are we taking 1 piece from each?
You get more.
We're going to get more pieces, right? Because we're not talking about what the size of 1 piece is. We already know the size of the piece. The size of the piece was 1/3 of 1 hole. Okay? All right, now let's turn your papers over. All right, on the top here where it says center 1 water, what I want you to do is you guys found the value of each scoop, okay? So for, you guys are group 1, for water you guys had 7 scoops for the first one, right? So you guys already have 1 there. We did yours, group 2, right? For water, go ahead and put 6 for number 1. Group 3 for water, put 7 for number 1. And group 4, put 7 for number 1 for water. You know what that means is if I had 1 container and it took me 7 scoops to fill it up, that 1 container, the value of that scoop was 1/7. That means it takes 7 scoops to equal 1 container. And you see how there's a chart here where you have your containers and then you have your number of scoops. Okay? So let's go ahead and fill in number 1 for the whole way, and then we're going to finish up the rest tomorrow. Look at your pattern blocks for number 1. put in your correct number for what you've had for pattern blocks. For oatmeal, go ahead and put in your correct number for the number of scoops it took your group for that one, and then for cubes, which says blocks there. Put your number in. And then we'll talk about the rest of this tomorrow.
What is Smith on?
Oh, yeah.
What is the E stand for?
We're going to talk about that tomorrow. Miss Farmer's
Can I
already
throw
with
a
you.
rest in while we like?
If you understand what to do, you can, but you're only going to have about a minute left. Yes. The 1/3 was the value of the scoops. You guys had 3 scoops for that. That 1/3 was just the value of your scoop. So we'll talk about this and continue with this tomorrow. Any questions about what we did today? Okay, guys, it's really, really important that you understand that this is not 9/27s, because we're not taking 1/3 from each. We're trying to figure out how many thirds can you make if you had 9 holes. If you were to draw that, can you imagine 9 holes? Whether it's squares, rectangles. Here they made long rectangles this way. You could have the containers, 9 containers. And even though it doesn't say how many scoops, we're just saying how many thirds. Well, if you understand that 1/3 is 1 out of 3, I know that I've got to scoop 3 times. So you kind of want to remember what we did today, because that's going to help you in problems like this later. Realizing that I'm not taking a third. Those are equal sharing problems. That's if I had 9 cups of flour and I want to share it with 3 friends.
Yes.
This would be friend 1, friend 2, friend 3. Friend 1, friend 2, friend 3. We're not sharing it with friends. We're trying to find out how many thirds are here. You can count them. You can see them. There are 27 thirds. This is not, let's give 1 piece to my friends from every hole. So you got to understand what the problem's asking you in context to the problem. Dennis?
No.
You sure?
Yes.
Good job, and make sure your names are on these, and I'm going to collect them on the way out.